Hi everyone, welcome back to our series. Hope you're doing good. This is Mahesh. In this video, we will look into Leetcode problem number 283, move zeros. Let us look into the statement of the problem. So it states, given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. Okay. So note that you must do this in place without making a copy of the array. And they have given some examples, and after that, if you see the constraints, our length of nums array lies between 1 and 10 raised to 4, and the number in the array nums array lies between minus 2 raised to 31 to plus 2 raised to 31 minus 1, basically int 32-bit number. Okay, with that, let us move to our editor and try to understand this problem a bit more. So now in this particular example, they have given this particular nums array. So it contains few zeros. Okay. Now what we need to do, we need to move these zeros at the end. So it means now my array looks something like this, comma 0. If you see this one here, 1, 3, 12, these three maintain their order in the way they appear in the original array, and then finally at the end we keep the remaining zeros. So this is the problem, and also we have seen the constraints. Maybe with that, what you can do, you can pause for a second and you can think for any possible solution, and if you are not able to solve, you can come back and you can watch the video. So with that, now let us try to understand what is the idea or intuition behind this problem. So what interviewer will be looking at you when they give the problem to you. So they want us to solve this particular problem basically in O of n time complexity and O of 1 space complexity. What this means, they want us to solve this particular problem in place. Okay, they don't want us to use the extra space here. So with that, maybe what we can do, we can start with our brute force solution. So now if you look into this particular array, and if you want to move these zeros at the end, then what is the extreme brute force way that you can think of? You leave about the space complexity and all. So what I will do, so I will take one more array of the same size, then I will check each number. I will iterate and check each number. If it is not 0, then I'll move number to this array. So I will see 0, it is 0. I'll see next 1. So 1 I will take and place it here. Then I will see 0, I will leave. I will see 3, I will take 3 here. Then I will take 12. And after that, remaining places, I'll fill it with 0. So now if that is the case, how do we do that? So 0, 1, 0, 3 and 12. So it is of length 5. So I will take one more result array. Of same length, that is n equal to 5. Now what I will do, I will start here. This is 0. So I will ignore this and I will move further. Now I get 1 which is not 0, so I will take and place it here in the results array. Next what I will do, I will go to next number. Again it is 0, so I'll skip that. I'll go to next number. I will take 3. Then I will go to next number. It is 12. Now I am done. I'll stop, and for the remaining places I'll simply put 0, 0. Okay. So now let us see the pseudocode for that. So let us we need this particular result array, right? So result equal to new array of length n. N will be nums dot length. Okay. Now what I will do, I will have to iterate in this results array, right? I will have to iterate over this particular array and this particular array, and I will have to keep pushing the elements. So for that, to move the places in results, I need a separate index. So what I will do, I will take a index variable and I'll assign it with 0 initially. Okay. Now what I will do, I will use a for loop for I equal to 0, I less than n, I plus plus. What I will do, I will check if my nums of I, if it is not equal to 0, then what I will do, I will say result of index equal to nums of I. Okay. Then once after this, I need to increment this index because next time it should place the number at the next index. So I will say index plus plus. Okay. Then I will close this loop. After that, assume there are 3 numbers which are not zeros. Then the remaining indexes also I need to fill, right? So for that, what I can do, while index is less than n, what I will simply do, I will say result of index equal to 0. I will simply fill the remaining empty blocks to 0. So this way, what we can do, we can come up with this particular result. Okay. Now after this, what you can do, you can simply use a for loop for I equal to 0, I less than n, I plus plus. Then you simply say nums of I equal to result of I. This will copy back the elements. Copy elements back to nums array. Okay. So if you see here, once what I did with this loop, I simply copied the number to result array, and then after that, using one more loop, what I did, I copied back the elements from results array to my original array. If that is the case, what is my time complexity? It is of order somewhat 2n, correct, right? What is the space complexity? I am using this extra results array, so which is of length n, that's why it is of order n. Okay, so this is the extreme naive solution for this particular problem. Now this is the problem for us. Now we will have to improve this one. So what I will do, let us see what I will do. I will again take the array which is 0, 1, 0, 3, 12. 0, 1, 0, 3, 12. This is my array. Okay. Now what I will do, I will try to move my non-zero numbers towards left. My non-number zeros towards left. Okay. So I will move this here. Then I'll move my 3 here. Then I'll move my 12 here. Then the remaining places, I will simply place them with zeros or replace them with zeros. So let us try to do this in place now. Now what I will do, I will put 2 pointers here and another here. Okay. This red pointer is basically to point to the 0 value, and other pointer will simply iterate and it will check the non-zero numbers. Now what it will do, it will check 0. So since it is 0, now this will simply move to next number. Now we got non-zero number, correct, right? Now what it will do, it will move this one. So basically it will actually copy paste. So it will copy paste this value with 1. Okay. Now our pointer, this pointer move towards next, and previous pointer, I mean the red pointer moves to the next number, and this pointer moves to the next number here, something like this. Okay. Now again it is 0. So this will skip and it will go to next number. Now we got a non-zero number. So what we will do, we will simply copy that number here. Then we will move this pointer towards next index. This pointer will also move to next index now. Okay. Now again we got a non-zero number. So what I will do, I will simply copy this here. So I will remove this 0 and I will copy 12. Now our pointer will move to next number and this pointer will move out of the array. So now we moved all the non-zero numbers towards left, right? Now if you see this particular point, it is still pointing at this point. It means our zeros should come and sit here. So I will simply move this, I will make it 0 and I will move this to next. Then I will make this also 0 and I will move this next. That way it got exhausted and I will stop here. So now if you see, we were able to do it in place. We didn't use any extra result array. Okay, let us try to write the pseudocode for that. So what I will do, I will take one index and I will assign it to 0. So this is basically the index of the 0 pointer. Okay, so this index point will point to the 0 value. Now what I will do, I will take a for loop after this for I equal to 0, I less than n, I plus plus. Okay, so this is basically our white pointer which was pointing to non-zeros. Okay, now I will check if nums of I, if it is not 0, then what I will do, I will say nums of index equal to nums of I. Okay, then after this I need to increment my index pointer as well because it needs to point to the next value. So this way it will, what it does, it will copy all the non-zero or it will move all the non-zero numbers towards left. Then at the end our index will be pointing to somewhere here which needs to be replaced with 0, correct, right? So what I will do, I will again use a while loop. You can use for loop as well. So while index is less than n, what I will do, nums of index equal to nums of, it should be simply 0. I need to replace that with 0. Okay, after this I will increment my index. Okay, so this way we will be able to move all the zeros towards right. So now if you see, it took 2 passes, basically one pass in this loop and another pass in this loop. So successfully we are able to move the zeros towards end in O of 2n time complexity. But if you see the space complexity, it is of order 1. So this we need to note. This is the improvement. We boil down the space complexity from O of n to O of 1. Okay. So let us execute this and see. Let's take a variable int n equal to nums dot length. After this, I will take a variable index and initialize with 0. Now what I will do, I will use a for loop for int I equal to 0, I less than n, I plus plus. Now I will check if nums of I, if it is not equal to 0, if it is a non-zero number, then what I will do, I will replace my nums of index with nums of I. Now after that I need to increment my index. So I will do this way for better readability. I will increment it here itself. Now this will make sure it moves all the non-zero numbers towards the left. Now at the end, this index will stop at a point where our zeros should be there. So I will take a while loop. You can also take a for loop here. While index is less than n, what I will do, I will say nums of index plus plus equal to nums of, sorry, it should be 0. We need to assign zeros. Okay, with this, let us try to run this and see. If you see, our solution got accepted. I will submit the solution. If you see, the solution got submitted successfully. So is there any better way? We are doing it in 2 passes, right? So is there any way we can reduce it to 1 pass? Maybe let's see. So here we will use 2-pointer technique. So what we will do, we will check for non-zero number and we will try to swap with zeros. Okay. So I will take the array again, 0, 1, 0, 3 and 12. I think this is the array. Now what I will do, I will see 0 here, then I will check for non-zero number. Now if that is the case, I will swap them. So if I swap them, my 1 comes here, my 0 comes here. Next I have a reference of 0 here. Then I'll go to next number. Again it is 0, so I'll go to next number. Now we have 3 here. So what I will do, I will swap this with 3 and this 3 with 0. This 3 with 0. Now my next 0 is here. Now I will go to next non-zero number. Then I will swap that with this particular 0. Then 0 comes here. Now if you see, we try to move 0 towards right. Correct, right? So that way, I mean, we can easily do this in one swap. Now after this, we don't need to replace anything with 0. So zeros are being retained and they are shifted towards right. Okay, let us see that in action now. So again, this pointer is for 0 and this pointer is for non-zero. Since this is 0, this pointer moves towards right. Correct, right? Now if you see, we get a non-zero number. If that is the case, we will have to swap them. So I will swap them. I'll remove this. This becomes 1 and this becomes 0. And after this, our red pointer moves towards the next available index. Next, this pointer moves towards right. Okay. Again, this is 0. Then I will have to simply move if it is a 0. Then I'll go to next number. Now I got 3, which is a non-zero number. Now we will simply swap this and this number. Okay. So I will do that. So I will do something like this. I will swap it here only. So now our red pointer should move to the next index and this pointer should move at the end, last index. Now again, since this is a non-zero number, we will have to swap them. So I will swap it and this will be 0. Now my pointer moves outside and this pointer moves here. Now once this pointer gets exhausted, if you see, all the elements are in the desired order. Zeros moved at the end and the remaining numbers are at the beginning with their original order retained. This way we can do this in one pass using 2-pointer technique. So basically we used left pointer to point to 0 and right pointer to point to non-zero number. So let us write the pseudocode for that. So I will take a left pointer. I'll point it to 0. Now my right pointer, what it did, it iterated over the array. So I will use for right equal to 0, right less than n, right plus plus. Now if nums of right, if it is not equal to 0, if it is a non-zero number, then what we will do, we will swap nums of left comma nums of right. Okay. After this, we will have to increment our left pointer. So I'll do that, left pointer plus plus. Then this is done. So at the end of our for loop, our zeros will be moved towards right. Okay. So this is the pseudocode of the most optimal solution. Now, if you see the time complexity, we are moving in single pass. That's why it is of order n. And if you see the space complexity, we are not using anything extra. So our space complexity is order of 1. So this way, we boil down the time complexity to linear time complexity. So that way, this is the most optimal solution. Okay, let us try and execute. I will remove this part. I will say this as the left pointer. Okay, then I will use a for loop for int. You can also use the while loop here. Since I can easily iterate the right pointer from 0 to n, I am using for loop. So there is nothing wrong in using for loop or while loop here. So right less than n, right plus plus. So int right equal to 0, right less than n, right plus plus. Now what I will do, I will check if nums of right, if it is a non-zero number, then we need to swap. So I will take a temp variable. I will say nums of maybe left, then nums of right, left equal to nums of right, okay, and nums of right equal to the temp. Okay, with this, we moved all the non-zero numbers towards left and we shifted zeros towards right using two-pointer technique. Okay, let me run this. There is some issue. It says yes. So what we are doing wrong here, we forgot to increment our left pointer after this. So I will increment that here, or for better readability, what you can do, you can simply increment that here as well. So let's run. This is accepted. Let's submit. Our solution got submitted successfully. Okay, this is the most optimal way of moving zeros towards the end. Hope you liked the explanation. If that is the case, please consider subscribing to my channel and also like the video, share it with your friends. And thanks for watching the video.